Hello, Matthews Gatos here. In this video, we're going to cover section 3.3, but before we do that, let's review 3.2. So in this first example here, p of x is divided by x plus 2 and the remainder is 4. I want to know which of the following statements is true. So if it's divided by x plus 2, that is your factor, which means that your root is x equal to negative 2. So the remainder theorem says put in your root, which is negative 2, and if you have a remainder of 4, the value of your polynomial when x equals to negative 2 will have a value of 4, which makes D your answer. Let's look at this question here. So this one here, we have a cubic function, and it's divided by x plus 1, and the remainder is 5. But I want to do the remainder when it's divided by x minus 1. So when it's divided by x plus 1, the root is negative 1. So the value of the polynomial when it's negative 1 has a remainder of 5. So let's substitute in x. So x cubed plus k times negative 1 squared minus 2 times negative 1 minus 7. And that whole thing is equal to 5. So negative 1 cubed is negative 1, plus negative 1 squared is 1 times k. Negative 2 times negative 1 is positive 2, minus 7 equals 5. So what this is altogether here is k, and then negative 1 and 2 and negative 7 altogether is negative 6. Add 6 to both sides, and k is equal to 11. So what that tells me is the missing value in the polynomial. So my polynomial is x cubed plus 11x squared minus 2x minus 7. Now I want to know the value of the remainder when this polynomial is divided by x minus 1. So x minus 1 is the factor, which means the root is 1. So I want to know the value of this polynomial when I substitute an x value of 1. So I have 1 cubed plus 11 times 1 squared minus 2 times 1 minus 7. So I have 1 plus 11 and then minus 2 minus 7. So combining all of my terms together here, 1 plus 11, take away 2, take away 7, and I get a value of 3. So that means the value of my polynomial at 1 is 3, and 3 is therefore the remainder. Okay, let's try another question. So in this question here, we have a rectangle that has an area of 2x squared plus 3x minus 20, and I have a length of 4. I want to know what the perimeter is. So I know that area of a triangle is length multiplied by width. So I have my area, 2x squared plus 3x minus 20, and that's going to equal to my length of x plus 4 multiplied by my width, which I do not know. So I'll just multiply that by width. So what I can do here is factor my quadratic here. So 2x squared plus 3x minus 20 factors as 2x minus 5 multiplied by x plus 4. And that will be the same as equal to x plus 4 multiplied by the width. So I see that I have an x plus 4 on both sides of the equation. So those are equivalent, meaning that 2x minus 5 must be equivalent to the width. So now that I know what the width is, I can look at the perimeter. So let's look at this rectangle here. So the perimeter is going to be the distance around. So I have my widths labeled as 2x minus 5, my lengths labeled as x plus 4. So my perimeter is going to be the distance all the way around. So let's look at my x. 2x and x and 2x and x. All together, that perimeter is 6x. And then let's look at our numbers. Negative 5 and positive 4 plus negative 5 plus positive 4 altogether is negative 2. So the perimeter is 6x minus 2 centimeters all the way around. Okay, in this video, we're going to look at section 6.3, which is the factor theorem. We're going to look at what is the factor theorem, how is it going to help us factor polynomials, and understanding the relationship between linear factors of a polynomial expression and the zeros of the corresponding function. So let's just start with numbers. It's always easier to see with numbers. If I have the number 7, I want to know, is 3 a factor of 7? Well, what does that really mean? It really means when I divide 7 by 3, do I end up with a remainder? Well, 7 divided by 3 is 2 with a remainder of 1. So since there is a remainder, which means there's leftovers, it is not a factor of 7. Let's look at, is 3 a factor of 12? Well, to look at that, I look at 12 divided by 3, and that's 4 with no remainder. So is it a factor? Yes, it is, because it has no remainder. So to determine whether a polynomial is a factor of another polynomial, we just have to see, is there a remainder or not? So the factor theorem then really is a special case of the remainder theorem. So if a polynomial p of x has a factor of x minus a, well, that can only be true if the value of the polynomial for a equals 0. So in other words, if x minus a is the factor and x equals a is the root, then this is only true if the value of the polynomial for a equals 0. Now, similarly, if your binomial is plus, it's just the opposite. So if p of x has a factor of x plus a, that's only true if the value of the polynomial for negative a is equal to 0. So negative a is the root, the x-intercept, the 0, the solution, etc. And for it to be a factor, the value of your polynomial at negative a has to be 0. So really just remember that factors and their roots are opposite of one another. So let's try this question here. I want to determine if x plus 2 is a factor of this polynomial. So if x plus 2 is the factor, then negative 2 is the root. So I want to know, does the value of the polynomial at negative 2 equal 0? So plugging in negative 2 in place of all of the x's, using brackets for my substitution, I want to plug that into my calculator and see if the value is 0. Okay, you can see the value is 24, not 0, so that means that x plus 2 is not a factor of the polynomial. Let's try that for the next one. So I want to determine whether x minus 3 is a factor of x cubed minus 7x minus 6. So x minus 3 is equal to the factor, which means that positive 3 is equal to the root. So I want to know the value of the polynomial at 3. Is that equal to 0? So substituting in for my x's, I'm going to have 3 cubed minus 7 times 3 minus 6, and I want to know, does that equal 0? So I can plug that into my calculator, and since it equals 0, that means that x minus 3 is a factor of the polynomial. So what if you know what factors, or sorry, what roots make it equal to 0? What's the corresponding factor that goes with that? Well, remember that factors and roots are opposites of one another. So if the value of the polynomial at 4 is 0, that means that x minus 4 is equal to the factor. If the value of the polynomial of negative 3 is 0, that means negative 3 is the root, and the opposite, x plus 3, is the factor. If the value of the polynomial is 0, the value of the polynomial at x equal to 0 is 0, that means that just x by itself is equal to the root. So we have the corresponding factors and the corresponding roots. Just remember that roots and factors are opposites of one another. So they are opposite of one another. Okay, so let's use the factor theorem to now help us factor. So what we're going to do is we're going to determine all of the potential integral zeros. Those are all the positive and negative factors of the constant term 12, for example, here. And we just have to find one value of x that makes it equal to 0. So here's all my potential integral zeros, all the factors positive and negative of 12. So all I have to do is plug in and find the right one that works. Or to be a little bit more efficient, let's put this into our calculator and look at the table value to help us. So that's exactly what I'm going to do. So I put my equation into y1, and then I look into my table for one of those potential integral zeros and find one that works. So I find one that works here, p of 1 equals 0. So that means if 1 is the root, x minus 1 is the factor. So I'm going to use synthetic division to find the other factors. So I'm going to take my cubic polynomial and divide it by my binomial factor. So remember, for synthetic division, I just get rid of all of my x values. make sure everything's accounted for, which it is. -1 goes on the outside here, and then the coefficients are all here. So 1, -9, 20, and -12. So I'm going to bring the 1 down and multiply. -1 times 1 is -1. And then I'm going to, like division, subtract. So -9 take away -1 is -7. No, it's -8. Silly. 9 take away 1 is not 7, it's 8. Okay, let's try that again. -1 times -8 is +8. And 20 take away +8 is 12. -1 times 12 is -12. -12 take away -12 is 0, which is great, which means that there is no remainder, which is what we expect because it is a factor. So this is my remainder, this is my constant, this is x, and this is x squared. So putting it all together, what I really have right now is x minus 1 times the quadratic. So all I have to do is break down the quadratic. So I know that factors as x minus 6 and x minus 2. So this would be my final answer as to how it factors. Again, you know, I'm a big fan of the check, so I would put the original question into y1, how I think it's factored into y2. The check always happens in the table, and you can see those match, so I know I've done it correctly. Let's try another one. So for this one here, I want to factor it. So again, I'm going to look at my constant term of 6 and list out my potential integral zeros. The reason I do that is because when I'm looking at the table, I want to know what factors should I really be looking for, just to kind of speed the process up. So there it is in my calculator, and in my table, I find that -2 works. So the value of the polynomial at -2 is 0, which means that x plus 2 is the factor. So I'm going to take this polynomial and I am going to divide it by x plus 2. And for synthetic division, remember, you just get rid of all your x values. So getting rid of all of my x values, I set it up for synthetic division. So 2 on the outside, and then 4, 12, 5, and -6 on the inside. And I begin the process. So I bring the 4 down and I multiply, and like division, I subtract, and then I multiply, and like division, I subtract, and then I multiply, and like division, I subtract, and I get 0, which means that I have no remainder, which is what I was hoping for. So this is my remainder, this is my constant, this is my x, and this is my x squared. So what I have so far is that this cubic function breaks down into 4x squared plus 4x minus 3 multiplied by the potential integral 0 I found was -2, so the factor was x plus 2. And then all I have left to do is factor this quadratic, and then I am done. So I know it factors. Always worth a check in the graphing calculator just to see if you've done it correctly. So original in y1 and the factored answer in y2, and you can see the check always happens in the table, and I can see that those are equal. So let's try one. This time we're going to try one that has degree 4. So it's just going to be a couple more steps of this process. So if I want to factor this quartic function, I'm going to find a potential integral 0, and I'm just going to look at the integer zeros, which is 3. So I'm going to look at all the factors of 3 and just find one that works so that I can break it down. So in my table, I enter my equation into y1, and in my table, I see that -1 works. So since -1 works, I'm going to divide this polynomial by x plus 1. So divide it by x plus 1. Now using synthetic division, you just ignore the x's and just use the numbers to go through and divide. So that's exactly what I'm going to do over here. So I have 1, and then 6, -13, -17, 5, and 3, and I use synthetic division to break it down. So bringing the 6 down, and then I multiply 1 times 6. And then -13 take away 6, -19. 1 times -19 is -19. -17 take away -19 is 2. 1 times 2 is 2. 5 take away 2 is 3. 1 times 3 is 3. And 3 take away 3 is 0 for the remainder, which means I did that correctly. So that's the remainder. 3 is the constant. This is x, x squared, and x cubed. So through the process of synthetic division, I've taken my quartic function and I've broken it down into a cubic and a binomial. So I have my cubic and my binomial. So I just want to continue breaking that cubic function down. So again, I can go back to my table of values. It's the exact same polynomial I started with, and I've already used -1, so the next one I see is +3. So since the value of the polynomial when x equals 3 is 0, x minus 3 is the factor. So I'm going to take my cubic function and I will divide it by x minus 3. So again, when we're doing synthetic division, we ignore the x's and we only use the numbers. Okay, so I am dividing that cubic function by x minus 3. So -3 goes here, and then 6, -19, 2, and 3. So I'll bring the 6 down, and then I multiply, and then I subtract. -19 take away -18 is -1. -3 times -1 is 3. 2 take away 1. Sorry, 2 take away 3 is -1. -3 times -1 is +3. And 3 take away 3 is 0, which means I've done it correctly and I have no remainder. So let's write out what we have now. This quartic function is now a product of two binomials multiplied by a quadratic. So I can just factor that quadratic, and that factors as 3x plus 1 and 2x minus 1. And now my whole quartic function is factored. So again, I want to check just to see, did I do that correctly? So original into y1, answer into y2, check always happens in the table, and you can see that they are equal, so I know I did that correctly. So that's factoring. Solving really isn't that much more of a step. It's just one little extra step. So to solve a polynomial algebraically, you're going to factor the polynomial fully, set each factor equal to 0, and solve each factor. Then you state the final solution and, of course, check it in the original equation. So let's look at an example of what we've done so far. So we factored the following polynomials so far. We factored this cubic function, and it had 3 binomial factors. So based on that, remember that factors and solutions, x-intercepts, they all mean the same thing, are opposite values. So my solution would be the opposite. So opposite of -1, +1. Opposite of -6, +6. Opposite of -2, +2. So that would be my solution. Okay, next one here, it factors into 4 binomial factors. So my solutions are the opposites. So the opposite of -1 is +1. The opposite of -3 is +3. The opposite of +1 is -1. And then the opposite of multiply by 3 is divide by 3. The opposite of a -1 is a +1, and the opposite of times by 2 is divide by 2. So those would be all of my factors. So for these ones here, to go from factors to my roots, I just use opposites. So again here, to go from factors to my roots, I use opposites and bottoms up if I have a fraction. So opposites and bottoms up. What do I mean by bottoms up? Let me show you. So opposites and, that does not look like a very good and. Let me try that again. So opposites and bottoms up. So what I mean by bottoms up, there we are. Let me just show you here. So for example, if I have divide by 3, my bottoms go up to be a +3 in front. See here, I'm dividing by 2, that's my root. My factor bottoms up becomes 2 in front. That's what I mean by bottoms up. Now, these ones were all really nice because they could be factored, but just as a little note, if a quadratic cannot be factored, if it can't be factored, that doesn't mean it can't be solved. It just must be solved using the quadratic formula. So if a quadratic cannot be factored, I want you to solve it using the quadratic formula. So don't think just because it can't be factored, it can't be solved. So let's try a question where we're going to solve this time. So we're just going to take it that one extra step. So looking at this, I'm going to look at my potential integral zeros of my constant number, my number all by itself, the y-intercept. And I'm going to go into my graphing calculator, just find one that works. Okay, and I see that -1 works. So since -1 works, that means x plus 1 is the factor. So I'm going to take my cubic function and divide it by x plus 1. So I'm using synthetic division, and remember with synthetic division, you just ignore the x's and you divide using just the numbers. So ignore all of your x's and divide with just the numbers. So in this example here, I'm going to take 1 on the outside and then 2, 3, 8, and 7. So I'm going to go through and divide that. So bring the 2 down, and 2 times 1 is 2. 3 take away 2 is 1. 1 times 1 is 1. 8 take away 1 is 7. 7 times 1 is 7. 7 take away 7 is 0. And yes, I've done that correctly. So what I have right now is I have x plus 1 times 2x squared plus x plus 7. So looking at that, I want to now solve. So this here cannot be factored. This is unfactorable. There are not two numbers that multiply to positive 14 and add to 1. So since it is unfactorable, I need to use the quadratic formula. So I already know that this here has a solution of x equal to negative 1. I want to find out what my quadratic has a solution of. So I'm going to do x equals opposite b plus or minus the square root, b squared minus 4ac all divided by 2a. So this is just going to be negative 1 plus or minus. So 4 times 2 times 7, that's 54. And then 1 take away, no, that's 56. 56. 1 take away 56, that's a negative 55. All over 2 times 2 is 4. Now this, you can't take a square root of a negative, means that there is no solution. But we have to always check that using the quadratic formula. So just x equal to negative 1 is the solution. I always want to check that on my calculator just to see did I do that correctly. So I can enter my quadratic in and you can see that just at negative 1, that's the only solution I have. So always a good idea to check that. Okay, for this last question, I want to end with a word problem. So for this one here, I have 3 consecutive integers have a product of negative 210. What are these integers? So first of all, what does consecutive mean? Consecutive means one after the other. So for example, I could have 1, 2, 3, or 4, 5, 6. So I start with a number and I add 1, and then I add 2. I start with a number, I add 1, and then I add 2. So I could have x, x plus 1, and x plus 2. So same thing, I start with a number, I add 1, and then I add 2. Those would be my consecutive numbers. So I have x times x plus 1 times x plus 2 equals to negative 210. So let's distribute this in. So I'm going to distribute the x inside here. So I have x squared plus x. Only distribute it once. I have students that like to distribute it into both the brackets, but then you'd be multiplying by x squared. So apply the distributive property. I have x cubed plus 2x squared plus x squared plus 2x, and then I'll add 210 to both sides to set it equal to 0. So grouping my like terms, I have x cubed plus 3x squared plus 2x plus 210 equals 0. So what I want to do is go into my calculator, looking at factors of 210, find out which one actually works out to be a potential integral 0, like which one works out to be an actual equal to 0. So the potential integrals zeros of 210 are listed out there. I go into my calculator, I just need to find one of them that works. So I find that negative 7 works. So since negative 7 works, x plus 7 is the factor. So on the outside, when I do synthetic division, again, remember that means to get rid of your x's. So I use getting rid of my x's, imaginary 1 in front, get rid of my x, get rid of my x. So notice on the inside I have 1, 3, 2, and 210. And then getting rid of the x, I divide by 7 on the outside. So bring the 1 down. 7 times 1 is 7. 3 take away 7, negative 4. 7 times negative 4, negative 28. And then like division, I subtract. 2 take away negative 28, 30. 7 times 30, 210. And 210 take away 210 is 0. And so I'm happy because I have no remainder. So what this tells me is that this factors as x plus 7 times by x squared minus 4x plus 30 equal to 0. Now, two numbers that multiply to 30 and add to negative 4, that's not possible. This is unfactorable. Now, that doesn't mean that there is no solution, but because it can't be factored, I know there's no integer solution. So if this was just a straight solving question, I would then take the quadratic formula and I would solve it. But since these are integers, this solution is not going to help me. So it looks like the only solution that will help me is x equal to -7. So if we go back up here, what did we have? We had x plus 1, and x plus 2. Those are my 3 consecutive integers that have a product of -210. Okay, to summarize this lesson, to factor a polynomial, you find just one potential integral 0 that makes the value of the polynomial equal to 0, and then use synthetic division to find the other factors. When you're solving, it seems like a lot of steps, but you're going to factor it, set every factor equal to 0, and if it can't be factored, as in a quadratic, you use the quadratic formula, and you set each one of those to 0, and of course, always check your answers. Thought this cartoon was cute. Little student says to his teacher, wait a minute, you knew x was 7 the whole time and you never said anything? And that's kind of the way it goes with solving. Lots of work to find a very simple solution. So I want you guys to do practice questions 1 to 7 in my notes. Detailed solutions, of course, are on D2L. And then you can go to the textbook after that. I hope this video helped, and I look forward to seeing you for the next one.